Black holes. Just the name itself brings up all these crazy images, right? Cosmic monsters, wild sci-fi adventures. But what are they really? Today, we're going to peel back all those layers of mystery and get right to the heart of what science actually tells us about these incredible things. So get ready, let's start our journey to the very edge of reality. All right, so let's just dive right in with the most basic question of all. Forget what you've seen in the movies, forget the comic books for a second. What exactly is a black hole? Well, the answer is somehow both way simpler and a whole lot weirder than you might think. So let's clear up the biggest misconception right away. A black hole isn't actually a hole at all. It's not some empty space you can fly through. Think of it as the total opposite. It's a place where a crazy amount of stuff is crammed into a ridiculously tiny space. This creates a gravitational pull so powerful that once you get too close, absolutely nothing can get away. It's like the universe's ultimate trapdoor, and not even light, which is the fastest thing we know of, can escape its grip. To really get a feel for a black hole's power, let's just think about gravity for a second. Earth's gravity, it's a pretty gentle pull, right? Keeps our feet on the ground. The sun's gravity is way stronger. It holds our entire solar system in place. But a black hole? That's a whole other level. This insane gravitational pull creates a boundary out in space, a point of no return called the event horizon. Now, it's not a physical wall or anything like that. It's more of an invisible line. Once you cross it, the laws of physics as we know them pretty much guarantee there is no coming back.
Okay, so where do these cosmic monsters even come from? Well, their origin story is one of the most violent and absolutely spectacular events in the entire universe, the death of a giant star.
So it all starts with a star, but not just any star. We're talking a true giant, many, many times bigger than our sun. For millions of years, it just burns away, shining bright. But eventually, it runs out of fuel. And with no energy pushing outwards anymore, gravity takes over and wins the ultimate cosmic tug of war. The star collapses in on itself in a fraction of a second, triggering this massive explosion called a supernova. Now, while the outer layers get blasted out into space, the core just keeps on collapsing, crushed down into a single point of almost infinite density. And just like that, a black hole is born. And, this is a really important point. Not every star has this kind of dramatic ending. Our own sun, for example, is way too small. It just doesn't have enough mass, enough gravitational oomph to collapse into a black hole. When its time comes, it's going to go out much more peacefully. So you can definitely rest easy knowing our home star isn't going to turn into one of these things. Okay, so we know how they're born, but now let's talk about scale. Just how big are they, and how many of them are actually lurking out there in the cosmos? You might want to prepare yourself because these numbers are truly mind-bending. So you've basically got two main types. First, there are the stellar mass black holes. These are the smaller ones, the kind that form when a single huge star collapses. They might be 5 to 100 times the mass of our sun, but all of that mass is squeezed into a space about the size of a city. And then you've got the supermassive ones. These are the true giants of the universe, with masses millions or even billions of times bigger than our sun. We find these titans at the center of almost every large galaxy, like a huge gravitational anchor. And yep, our own Milky Way has one right in the middle, called Sagittarius A star. And this quote really nails what's so wild about black holes. It's not just about how much they weigh, it's about their density. I mean, just try to imagine an object physically smaller than our planet, but with the gravitational pull of millions of Earths all put together. That's the kind of bizarre reality we're talking about here. So how common are they? Let's just start in our own backyard, the Milky Way galaxy. Scientists estimate there could be, get this, 100 million black holes just roaming around our galaxy. 100 million. And that's just here. When we zoom out and look across the entire observable universe, that number just explodes into the trillions. So these aren't some rare cosmic oddity, they are a fundamental and incredibly common part of the cosmos. Okay, but this leads to a really interesting puzzle. If nothing, not even light, can escape from a black hole, then how on earth do we know they're even there? How do you possibly find something that is, by its very nature, completely and totally invisible? Well, the reason a black hole is black is actually pretty simple, but also really profound. It doesn't make its own light like a star does, and it doesn't reflect any light that hits it like a planet does. Any little particle of light, any photon that crosses its event horizon is trapped forever. So the thing itself is a perfect void, just an absence of light in the cosmos. So that's the trick to seeing the invisible. When you look at those amazing images from our best telescopes, you're not actually seeing the black hole. You're seeing the chaos happening around it. As gas and dust from nearby get pulled in, they form this swirling, glowing donut of material called an accretion disk. The friction in this disk heats everything up to millions of degrees, making it glow super brightly. It's that cosmic death spiral, that final blaze of glory before matter takes the plunge, that we can actually see from Earth.
All right, we've talked about the physics, the crazy scale, and how we even managed to find them. But now we're gonna venture into the what ifs. To answer the ultimate question about what it would be like to experience one of these cosmic giants up close. This is the big one, isn't it? It's the ultimate sci-fi scenario. You see it in countless stories. But what does the real science say? What would actually happen to a person if they were to fall into a black hole? The experience would be, well, extreme doesn't even begin to cover it. First, you'd run into a process with a terrifyingly perfect name, spaghettification. The gravity would be pulling on your feet so much more powerfully than on your head that your body would literally be stretched, pulled longer and longer, and torn apart just like a piece of spaghetti. At the same time, something really weird called time dilation would kick in. To someone watching you from a safe distance, you would seem to slow down as you got closer to the event horizon, eventually looking like you'd frozen in time right at the edge before fading away. But from your perspective, you'd cross that event horizon, that point of no return, and just vanish from our universe forever. So, could you survive it? Yeah, the answer is a very clear, very definitive, and probably unsurprising no. It would be one of the most incredible and fascinating experiences possible in the universe, but it would absolutely be your last. So, it's really easy to think of black holes as just these cosmic vacuum cleaners, right? These agents of pure destruction. But if you only see them as monsters, you're kind of missing their true role in the grand cosmic dance. They are so much more important than that. Black holes aren't the villains of the story. In many ways, they're the architects. They're a natural, necessary part of the cosmic life cycle, the final chapter for the biggest stars. Their incredible gravity is actually a creative force, helping to shape entire galaxies and hold them all together. But more than anything, they're just this profound reminder that the universe we live in is far stranger, more wonderful, and more mysterious than we could ever have imagined. They push the very limits of our understanding, and they dare us to keep on exploring. We've learned so much about these incredible objects, but the truth is, we have only just begun to scratch the surface of their mysteries. It really makes you wonder, if something as completely bizarre as a black hole is a real thing, what other cosmic wonders are out there just waiting for us to find them?